Okay, we're going to talk about this thing called confidence intervals now. Now, let's think about it in terms of this. If I were to stand in the room and guess what the height of the next person coming through the door would be, I would say if it's a guy, it's going to be about 5'10". Chances of me being right, though, are pretty slim. Even though 5'10" is the average height for men, you could have someone who is 5'9". That wouldn't be unrealistic. You could have someone who's 5'11". That also wouldn't be unrealistic. And at the same time, I would argue, well, I said 5'10", it's 5'9". That's pretty close. That ought to be good enough. You say, no, that's not good enough. You say, fine, let's make a wager. Next person through the door, I say, is going to be 5'10" exactly. Should I make that bet with you? Probably not. Because again, even though 5'10" is average, my chances of winning are not great. So if I were to guess that the next person through the door was 5'10" and or 70 inches, that would not be a great way to go, because I'm not entirely sure how many people are going to come through the door and how many are going to be exactly 5'10". On the other hand, if I said, hey, I think the next person through the door is somewhere between 68 inches and 72 inches, my probability of guessing the right thing actually went up quite a bit, because now it's not exactly 70 inches. It could be slightly below, could be slightly above. So in this case, I have everybody from 5'8" to 6 foot. In that case, I'm going to have a really good chance of winning this. So whereas you would definitely take this bet up here because I have a small chance of winning, you'd be a fool to take that bet because the chance of that happening for me is much, much better. So the idea is this is a point estimate. A point estimate is simply a single point, one number, one piece of data that best represents a group. However, if I wanted to be a little bit more vague, if I wanted to give myself a few more options, I could give myself an entire interval for data. So this was what we call a confidence interval. Now, on a confidence interval, it's a balancing act between being too small and being too large. I could say, I believe the next person in the door is going to be somewhere between 69.5 inches and 70.5 inches. That is not going to give me a real good chance of winning, because even though it's an interval, it's a very narrow interval. On the other hand, if I came in and said, I think the next person through the door is somewhere between 36 inches and 84 inches, well, my chances just got a lot better, but it's not as meaningful, because like, well, yeah, but that pretty much would cover everybody. That's not much of a cool trick to say, hey, unless you're just freakishly small or freakishly large, you're in. So the chances of me winning here are huge, but you'd be surprised how small an interval I can have and still have a really good chance. That's why we're going to do confidence intervals, but we're going to find a way to set the bars on the confidence interval so that they are both meaningful and reasonable. Okay, both meaningful and reasonable. What we're going to be going with is a 95% confidence interval most of the time. Now that can change. I could go down as low as 70, 60, 50. It could go as high as 99, 99.5 confidence. But usually 95 is our reason. And here's why. If you'll remember, on a standard normal curve, 2 standard deviations each way should give us 95% of the data. So if I simply choose basically plus 2 standard deviations this way and minus 2 standard deviations this way, it's going to make a lot of sense. So let's come up with a scenario to give you an example of confidence interval. Let's assume I have 25 people in a class, and I find the average for the men, so 25 men in the class, I find the average for men is 5 feet 9 inches. So 5 feet 9 inches or 69 inches. I want to be 95% confident that I'm going to guess correctly. Now, one thing we also need is we're going to need a standard deviation. But if I have 25 heights, I can find its mean. I could also find its standard deviation. Let's assume for now the standard deviation is 2.25 inches. Now, using this number, and this number, I can create a meaningful interval that's going to describe our data. To do that, I'm going to do the following. I'm going to take the general form of x bar minus z times s over square root of n is less than or equal to mu less than or equal to x bar plus z s over root n. Now, that's going to be our formula. Well, x bar we already know. That is 69 inches minus, I don't know z. I'm going to come back to that in just a second. Then we have the standard deviation of 2.25 divided by the square root of 25 less than or equal to mu less than or equal to 69. Now, you'll notice that's the same. That's a minus, this is a plus, but other than that, they're going to be the same again. In essence, what we're saying is I'm guessing at a middle based on my data, but I want to take that middle and I want to add a certain amount to be acceptable this way and subtract a certain amount to be acceptable this way. The only thing I don't know is the z or t. Now in our case, should we be using z or t? Well, we have a group of only 25, and additionally, I don't have an official population one way or the other. So t is probably the way we need to go. Let's go over here to the computer. And here we'll go back and we'll do that thing that we never talked about before, and that is using the both sides option and the middle option, because whether you do both sides or whether you do middle, that's what we're looking for. We want some of our loose ends over here. Want some over here. Now if I want 95% in the middle, all I have to do is type in 0.95 for the middle. Do make sure you put the decimal in. And it gives me a value of, just a second, I made a mistake. I need to be on normal. So 0.95 in the middle, I come up with 1.96, 1.96. Now you'll notice I come up with two options up here. I come up with positive 1.96 and negative 1.96. But I don't need to worry about that because my formula itself already has a minus and a plus sign in it. So it'll take care of it. So if I do all these calculations, I get the following answer. When I go and put this component into a calculator, you'll notice it's the same as this. I came out with 0.882 in both cases. This thing right here is actually the amount that we're going to accept one way or the other. This we call the margin of error, because it's going to be the amount of difference I accept going both ways. In this case, my final numbers turn out to be 68.118 less than or equal to mu less than or equal to 69.882. Now, The thing about it is, that's not a very wide margin, but it is wide enough if I had a sample of 25 people, because technically a confidence interval doesn't find the chance of the next person being this particular height. It finds the probability of the next group of 25 equaling a given height. So I am 95% confident that the next group of 25 students in the door, or the next 25 students that I have in the class, if I find the average height of those males, that it will be between here and here based on my original survey. That's what a confidence interval is. I'm going to do one more example, but we're going to go through it fairly quickly this time. All right, hold on tight. Okay, our example, in a 7-day period, a factory produced 283 items with a standard deviation of 14 items. What interval could the owner be 95% confident in for a 7-day period? This will be something that would be very important if you're going to be writing future contracts, to know what kind of production levels have you been using, what can you be confident in as far as being able to deliver on time. So here we go. We have N equals 7 days. We have an X bar, an average of 283 items with a standard deviation of 14. And I want to be 95% confident. Now technically, since it's a sample, it's going to be S. So we're going to say X bar minus Z S over square root N less than or equal to mu less than or equal to X bar plus Z S over square root of N. All right, 283 minus, now I want to be 95% confident, so again, I pull up my probability distribution calculator, and I say I want 95% in the middle. That gives me a positive 1.96 and a negative 1.96. However, if I said I don't want what's in the middle, I want what's on the outside, well, if 95% is in the middle, 5% would be on both sides. Calculate, that also is 1.96. But you'll notice we have a very small sample, only 7 days. So let's do a student T with 6 degrees of freedom, and I want 0.95% in the middle. Answer is, you'll notice it's significantly wider at 2.45 and negative 2.45. So by using student T rather than normal, we get a little bit wider run, 2.45. So we're going to put 2.45 here with a standard deviation of 14 all over square root of 7 less than or equal to mu less than or equal to 283 plus 2.45 times 14 over root 7. I'll do the calculations and be right back. Okay, we have 283 items minus a margin of error of 12.96 and 283 plus the margin of error 2.96. Final answer becomes 295.96, or 296 items, or 270 items. So 283 minus 13. That interval you can be 95% confident in. Now, by the way, while we're here, you can list it as an interval with two sides. You could also say that it's the same thing as 283 plus or minus the margin of error, 12.96. So it's X bar plus or minus the margin of error. Both of these are equal to one another. They mean exactly the same thing, and they're arrived at basically the same way. So that's confident intervals. We just have proportions yet to go, so one more video.